Well, now we'll talk about reversible isothermal processes. What we mean by it and what are the relevant equations for this kind of processes. So as usual, we first write that basic equation of first law of thermodynamics. I always stress on rewriting that first law of thermodynamics is so important, and everything can be derived from that first law of thermodynamics. So du is equal to del q minus del w. So I say isothermal process. What does that mean? That means del T is 0. In a PV diagram, if you see, these are the isothermal lines for a particular temperature. As a particular, let's say T1. So along these lines, there is no change in temperature. So your internal energy or the change in internal energy is 0 if there is no change in temperature, because internal energy is a function of temperature, provided P, V and T are the variables and where T is constant. So if P varies, V varies accordingly, keeping the T constant. So there is no change in internal energy. Therefore, del Q is equal to del W. As usual, we have no way to calculate del Q. So we'll always find del Q from del W equation. Now let's see how do we express del W in an isothermal conditions. Please remember, these are all reversible conditions and thermodynamic equations are applicable only for these reversible equations. Okay, so from ideal gas law, you know, PV is equal to RT, or let's say nRT, where N is the number of moles. If N is equal to 1, so it becomes nRT. So work done is, as usual, work done is given by P del V, or in differential form P dV integration V1 to V2. Now look at this curve. This pressure versus volume. Note here, pressure and volume both are varying. So I cannot integrate if I don't have one single expression in terms of V. So P has to be expressed in terms of V to make this integration possible. Okay. So from ideal gas law, if I can substitute the P from here, we get a direct equation. So what is P? P is nRT by V, right? So if I substitute directly from here, I'll just erase this part. So integration nRT by V dV V1 to V2. So this becomes nRT ln V1 by V2. So this is the final equation. Let us erase this part for the time being. So this is the work done is equal to del Q is equal to del W. This is the amount of heat, or that. What does it mean? That means is that for an isothermal condition, if some work is done on the system, okay, so to keep the temperature constant, the internal energy, that is the internal energy, will be 0. The change in internal energy will be 0. So if you do some work on the system, so it will increase the internal energy of the system. So what will happen is that some heat will be ejected from the system. So this term del Q is equal to del W will be there. So del Q minus del W is always 0. So you can also express the same expression in terms of V1 by V2, and you can just write this as this integration is